Hi, I'm going to make a notebook to help me craft filters for digital signal processing. So I'll be using a IIR, an infinite impulse response filter. It will be implemented as a digital biquad filter. Here's the formula we need. Here's a graphical representation of what the filter's doing. It's using weighted historical and weighted filtered values in order to derive the next filtered value. The B0, B1 and B2 coefficients determine zeros, and A1, A2 determine the position of the poles. A value that causes the numerator to be 0 is a transfer function 0, and a value that causes the denominator to be 0 is a transfer function pole. So let me start writing a class. When working with digital signal processing, one common thing you will want to do is to work out when the signal is steady, which is referred to as steady state detection. An easy way to do this is to look at the signal within a window of time and look how much each signal point deviates from its neighbor. One other common thing you'll want to do is to detect the peak of a signal, or perhaps the trough of a signal. And a simple way to do that is to look when the vector of the filtered signal inverts. So when the vector of the filtered signal goes from positive to negative, you know you've got the peak. And then when the vector of the filtered signal goes from negative to positive, you know you've got the trough. So here I've got a function that plots out a random signal, does steady state detection on the filter signal, does peak finding on the filtered signal, and then animates the plots. So here I've got the yellow crosses are the peak detection, and the red blobs are the steady state detection. And the orange line obviously is the basal filtered signal. So in a real world application, what I would do would be to take real world sample data from sensors and then replace this random signal with that real world sensor data. And then I would play around with the cutoff until I get the desired filtered signal. So let me, for example, increase the filtering on this signal. There we have the filtered signal lagging quite a lot behind the raw data. But if the raw data is very noisy, it may be desired to have such a filtered signal.